yeah, I fully expect some questions at the end. I don't want to go too much into everything because we will literally be here all night. But yeah, I will start. So my name is Chris Gelpi. I'm a quality specialist for assembly build in Rolls Royce motor cars. I have 18 years experience in vehicle manufacturing and repair. I've been at Rolls Royce for 13 years now. In my time at Rolls Royce, I've worked in various departments across the plant. I've been involved from sort of initial design concepts, testing of sort of parts, obviously manufacturing, dealing with part suppliers and customer support. My specialist background is I'm a coating specialist, so I'm a lot of sort of polyester lacquers, polyurethanes, things like that, and I was a BMW apprentice. My daily role now is a complex problem-solving specialist. So just to give you sort of a brief overview of kind of what we do, obviously we make cars. As a car manufacturer, we are a very low volume plant. Last year we sold 6,032 vehicles. And we produce currently 4 models. So Phantom is our flagship, the most expensive and the most complex to build. Ghost, Cullinan, and we last year just released our first all-electric car, which we run 1 production line for all these vehicles. So they have, very, very different specifications. So integrating them onto one line is very complex, especially running an internal combustion engine line with a BEV vehicle line integrated into it. So the first thing we kind of look at in controlling production quality is something we called FMEA. So it stands for failure mode effects analysis. So you basically have 2 choices in controlling quality. You can avoid it before with risks, or you can react after with problem solving. So the way it works in Rolls Royce and kind of BMW plants, FMEA is completed on all processes and products prior to production release. It basically identifies risks for quality topics and legal requirements. It's really there to mitigate the risks before the product is introduced. There's kind of 2 types of FMEA. One is design FMEA. So that has to be done before we even kind of go into a production environment. And yeah, what it does, what it is, and how it's made. These are all very important stages that we go through. Once the kind of design characteristics have been approved, then it gets kind of handed over to production, and that's what we kind of do. So for those of you who kind of are very new to FMEA, it basically is a very, very quick and easy way to figure out what process you have, what can go wrong with that process, what would be the result of that going wrong, and how serious is it. So that would be, and you basically score it 1 to 10, and that is your severity score. Then you look at what could cause the failure and how often would it happen. And then you mark that on a 1 to 10 score also. How might it be found? So what control methods do you currently have to detect the fault, and how effective is that method? And you mark that 1 to 10. And essentially, once you have all those questions to a particular process, you multiply your severity by your occurrence, by your detection, and that gives you an RPN. So that's a risk priority number. So generally, in FMEA, an RPN of more than 80 will require a corrective action. So this is just kind of one that I just found randomly online. So your effect to the customer says you're able to write less, the severity is a 7, what the causes are, what the production control is, that's your occurrence. What do you have to detect the problem? So obviously these, by this, is that would require a corrective action. So then you put in the corrective actions, whether that be increased detection or your prevention control is better, then obviously redo it. Yeah, and like I said, generally anything more than 80, you have to keep going. So once you've obviously completed all these, you can then release the process. Any kind of questions on FMEA from anyone? Okay. So quality is everyone's responsibility. To accurately problem solve, you have to have complete transparency, and that is very, very key to effective problem solving. The associates conducting the build are the most important assets of the company, and to be successful, you must involve and engage with them to successfully identify faults with them. If you operate a system as a company where there is hierarchy, so for instance, production and then a quality department that doesn't engage with them and isn't part of that team, you will never problem solve effectively. When you engage with associates, they feel valued, and they will proactively look for problems in their process and look for ways to improve them. Disengaged associates who are not involved, it will result in high DPU. So we calculate in the automotive industry for DPU, so that's how many defects per unit, and low RFT. So obviously, for those of you not aware, RFT is right first time. Yeah, and your associates, like I said, they are the most valuable. If they're not happy, it will cost your business massively. Rolls Royce promotes massively quality must be in the culture, and it has to be in everyone's daily business. It's a quality problem, it's an everyone problem. So there's kind of a few things that you can do to improve that. So one is we operate a CIP program, so that's a continuous improvement program. So you could have an idea, you input it into the system, and if that's a cost-effective measure for the plant, so that could be anything from moving a tool closer, which helps time. So time is always money in manufacturing, and the way we kind of promote that is associates receive a percentage of their cost saving. So say, for instance, you had something that cost 50,000 that you saved to the business, the associate may receive £500 for that. So it's a very good incentive for people like money. The other thing is you have to operate a no fault forward policy and a no blame culture. A blame culture does not help anyone. If you feel like you're going to be singled out or you're going to be blamed, you are not going to be open and transparent. You will hide everything. That's very, very important. The last thing is kind of cooperation is a must between all parties. So, for instance, you may have someone in assembly, someone dealing with bodies, someone dealing with parts. You must have all cooperation to effectively problem solve. If one of you hides something, you can't fix the problem. So we currently at Rolls Royce Motor Cars operate a DMAIC problem solving methodology. So that is an approved Six Sigma methodology. So the first thing you do essentially when you're highlighted with a fault, you need containment of that fault. So it's very, very important to get adequate containment for the fault, so you're not still producing faults. We classify faults in numbers. So a fault is classified, let's say, as an 8. That would be highlighted as it's intended to be. So if you highlight a fault as an 8, that's good. Low numbers, so for instance, if it's a 1, it could classify, danger to life or legal requirements for shipping cars in certain countries and things like that. So the first thing you would do is obviously system check what you have if you're identified a fault. Depends what the fault is. You can implement measurements in the system checks. So you can really analyze how many cars you have that are failing, or translate it to a construction business. How many how many things are wrong, how many and then we carry on and look at kind of level zero. So level zero analysis is kind of like the basics of problem solving. So I'll go into that in a bit. So once you identify the problem, you can contain it. You figure out a containment, and then you have a check and release system. So that allows you to ship products and be very, very confident in what you're sending, and you're not sending the fault forward. So the first phase of DMAIC is you basically have to define the problem. So you can use a range of different techniques to identify the fault correctly. So for a business like ours, we classify faults. It's either man or method, part, body, or conceptual topic. So to identify if it's a man or method topic, if it's a part that's not sitting right or something, you would remove and refit it. If you still get an NOK, then try a new part. It's very important to review the process documentation. So, and you process confirm the associates against that documentation. So for instance, if the associate is doing something different and deviating from the process, that could be a problem, but also it could be the process itself doesn't achieve OK. So the way you would identify parts is by measuring. So we have an in-house measurement analysis system. We can measure anything within sort of 3 decimal places of a millimeter. Very, very accurate. Body measurements. So obviously we use a range of materials to build our bodies, as I'm sure all of you do in your kind of daily works. So you can measure every aspect of that. And the last point is it's a conceptual problem. So this is where the engineers actually didn't do their job. So what we would classify as a conceptual topic is the parts and body. They're in specification, but say for instance, the part is high, so the part is too big, and then the body is too big, and it's fitted right, but then it still achieves NOK, then the fault lies with the engineering concept. You can basically define what what you're looking for, and you can use 5 whys root cause analysis. I don't know if anyone's used one before, but yeah, it's a very simple way of say what the problem is, and you just keep asking why. And it's called 5 whys, but actually you can go on for until you find it. Ishikawas, so they're very useful. You obviously highlight what you're going to look at. Generally, you would use an Ishikawa as a team. You never ever do this by yourself. So you would look at say man, materials, environment, measurement, machine, and method. You group all those together, and then you theory test everything and see what comes out of that. Measuring. So good data is a must. If you don't actually collect any data of what you're doing in your business, then you will never ever know how you're doing. And so we operate very, very, very good data. So all assembly stations, they're linked to an in-house data analysis system. This allows not only us as a quality team to log faults, but this allows the associates to log defects themselves they find in their day-to-day business. This system is linked to the whole plant, so everyone has access to this system. So it's not one department has access to this and the other one doesn't. It makes everything completely transparent. You don't hide anything. Because we operate a very complex production system, we need to install checks on certain things. So this allowing the associates to do all of this allows us to be able to install checks in their stations as well. So they all have a tablet, and when basically the car is scanned into their zone, we can analyze checks, so we can make that ping up when the car goes in. So we tell them you must check this, and is it okay or NOK? and they have the ability to take pictures of the fault as well. So then we can just look on the data and go, okay, this is how many failures we've had, and then you can identify, is it the correct failure by the picture? So we allow a certain amount of time into their process time to allow for all these checks. So then this data is fed into a system. That report of defects is sent forward for each station. So we can generate that and we give that to the leader of the station so they can monitor their RFT. Then more complex topics, we can export that data into Excel and then really go to town on highlighting, what type of it is, how many of it is, where's your sensor location. Then we can effectively use it to generate heat maps so we can identify where we need to look the most. We obviously use a lot of torque fixings and things like that. So for us, and I'm sure you'll all be happy, in most of the automotive sector, certain categories of fixings, seat belts, seats, things like that, we have the ability to ensure all fixings are correct and at the correct torque. We basically use what we call DC tooling. So measurements of the torque, we measure everything. So this allows for complete transparency. So if failures occur, so we can allow correct diagnosis of a specific fixing. We can look at the torque, if it's cross-threaded, the angle of the torque the fixing went in. So for us, we make it very simple. There's a red and green light on the gun, and they allow the associate to clearly identify if the fixing is okay or not okay. If it's not okay, it will flash red, and then they raise their hand. So in the measure phase, you can have you can use a kind of range of charts to measure. I don't know if some of you may use these on a kind of daily basis, some may not. We use a program called Minitab to generate charts. It's very, very good. You can use Excel, but Minitab, we find is much, much better. So if you're identifying and trying to measure RFT, you might use a scatter plot, which is the top. This basically identifies DPU over calendar weeks, so you can monitor each action. Histograms, so they're good for analyzing a large selection of vehicles to get averages and where your kind of nominal should be, and then kind of box plots. So they're good for comparison of measurements between different sides. So if you're all comparing, say, for instance, one side of a bumper to another. So your analyze phase. So like I said earlier, when you're conducting this analyze phase, you have to get everyone involved. So it's not a quality problem. It's not a production problem. It's not a planning problem. It's everyone's problem. If you brainstorm together, you get much broader ideas. So essentially, you input all the potential causes into ICWCI, which is the drawing on the left. Once ICWCI is complete, a series of root causes will be identified. And then as a team, you can brainstorm those improvements. So then you use your improve phase. So for instance, your improve phase could be literally just an alignment between one or the other. So for instance, for us, it would be kind of, paint or assembly. For you guys, maybe steel fixing and concrete. Literally, one of you just agrees to do something that would help the other, and that will improve the process massively. The other thing, it could be your actual measurement could be wrong. So then you would use what we call kind of a gauge R study. So your measurement method may be inconsistent. So it's not that the product's no good, just the way you're measuring it's no good. So essentially, you could measure the same thing 10 times with 10 different people, and what is your range of measurements? So it could just literally be you introduce a new measurement device that improves that massively. the next one could be tooling, things like that. It's very important on your improve phase that you don't change too many things at once, because you will, if you implement too many improvements at once, you don't know what impact that had to the process. So for instance, you would use a scatter plot to monitor that. So for instance, you can see in the picture, A is start the project, improvement 1 went, so you run it for a week or two. What did that do? Okay, then you would essentially implement another improvement. What does that do? You can't do too much at once. And the last one is control. So your change control overview. So this is the same chart as the previous page, sorry. You can see the top chart is over a small amount of time. So you can see, yes, we've made good changes. Yes, we're done. It's all good. And then 3 weeks later, it comes back. So it's very important to keep monitoring what you've done. So rather than start from scratch, you already have all the information of what went wrong last time. So then you would put in reactive measures again. And that is where a lot of problem solving goes wrong. You look at it for 3 or 4 weeks and go, yeah, we're done, next, and then it comes back. And that is how we kind of control quality in a nutshell. It's very kind of quick, and yeah, obviously if you got kind of any questions.
Yeah, Chris, we had a very similar problem about changing timberings when we were doing the concrete curing trials. It's a very frustrating process, and you have to wait for like days and stuff for the curing. And I remember inadvertently we made 2 changes instead of 1, and we had to go back to the beginning. So you're right, it's absolutely critical that you just do one thing at a time and then monitor it and measure it and see whether it's right or wrong. But that can be a very, very long and frustrating process.
It can, but if you don't do it correctly, you don't get the result you need. You have to go back and do it again, and then it just creates more time and more money.
When you say about, you were talking earlier about scanning the parts and stuff like that. Is that because you're in a 3-dimensional situation there with the body and the parts fitted to the body? How do you tell which one's wrong, or do you have to scan them all individually?
So you can scan them individually, or you can use something what we kind of call here. So it's called an ABA. So you basically take the NOK vehicle and an OK vehicle, and you swap parts from the good one onto the bad one, and swap parts from the bad one onto the good one. And does it follow the vehicle or does it follow the part? And there's a very simple analysis you can do to really pinpoint, is it kind of part or body?
Okay, yeah, that makes sense, I suppose. Because you've got several vehicles similar on the line, you can do that, I suppose.
Yeah, unless you've got 100% NOK, then you lose that option. Then you obviously have to go straight for a measurement.
So with the bodies themselves, do you actually how do you scan them for compliance? Do you laser scan them, or how does that work?
So we have what's called a plate. So that is zeroed 100%. So we know every measurement is good. When the bodies are made, they put them through a scanning device that will measure certain points. Not consistently on 100% of bodies, but we will have, say, 1 in 10 full bodies measured, so we know which way parts are trending, and then obviously that allows body to move back a bit if they're trending out.
Okay, so again, it's a monitoring process over various vehicles in a period of time.
Yes. Yeah.
Trends.
But bodies generally will steer out at points, presses, and tools and things like that become worn out. It will, over time, but it's never generally a big problem instantly. It's more of a kind of drifting in and out.
Okay. And obviously at the factory where they're manufactured, they obviously very tightly control that.
Yes.
Okay.
You had a slide earlier on FMEA, I think, Chris, and you had three areas, and you had them scored out of 1 to 10 or 0 to 10.
Yep.
Is that subjective or objective, sort of where you put the scale between 1 and 10? Because you might say it's a 3, and I'll say it's a 4. How do you actually pinpoint where you are?
Yeah, so that's why you essentially, you don't ever do this in one person. You do it as a team, and you're absolutely right. It can be subjective, but then if it is subjective, you would never do an FMEA with less than 4 or 5 people. So then you obviously take a majority. It's very unlikely that someone's going to score something a 1 and then someone's going to score it a 10.
I was pleased when I heard about the right first time culture of blaming, and also the system DMAC something. DMAC. It was quite interesting, and it's quite interesting to see how it works, considering that Rolls Royce obviously doesn't have the same number of workers like we have on our side, and also obviously the number of companies, because they are actually coming together, right? First times, blaming culture, and also that the system presented earlier, and also pinpoint and indicate something which Chris mentioned, which is that the fact that quality also drives productivity, profit, and also makes the things that speak quite well. And that's coming from a company which is quite well established.
Yeah.
And also quite well known for the high-end product that they are delivering at the end of the day. Rolls is a Rolls all the time. And again, it's made to last, which is also what somehow we are doing. And 60 years plus another 20 in case we extend the lifetime needs to be like at the beginning.
It does, yes, it does.
And I think we need to grab more from Chris and to understand some principles, how they are working, or also for us to play better, because obviously we are working all as a family, which bless us, we did succeed in many times, but obviously we can improve this.
Yeah, when we had a guy called Phil Britton, who was at ex-Toyota Director of Quality, and he was very much like Chris, process, not people. Always look at the process, whether the people are following the process or whether the process is even right or wrong. You always start off with the process and then work from there. And it's, would you say that was sensible, Chris?
Yeah, definitely. And we on a production line, yes, we run 2 shifts, but there's in excess of 3,000 personnel. So you're not talking, it's not like we're a little group, and we're a big company, and we sometimes get the analysis from people like, well, it won't work because there's too many people, and yeah, it does. The only thing you need everyone to be on board, and that comes from the top down. It doesn't come from the bottom up. And the blame culture, unfortunately, in most occurrences, comes from the top, because KPIs, unfortunately, are in the business that we're all in, and everyone has targets and things to achieve, but the end goal, we all have the same end goal. Production is the job, and we're all there to achieve that together. And getting to the point where the no blame culture is gone is a challenge, and it's still a challenge for us every day. But, you know, we always have to go back to production is the job. That's what pays all the bills. And that's the main goal. And everything else is there to just support that. It's not, you know, and yeah, like I said, the KPIs sometimes can be a problem, and that can put people's backs up, because if I'm not going to achieve my KPI, if I accept this topic, I'm not going to accept the topic. And yeah, that's sometimes where we can all fall short. You know, I don't know how it kind of works down there, but yours is a massive business as well, so I would assume KPIs are everywhere.
They certainly are. Yeah, it's true. Yes, I mean, obviously we've got to produce stuff because our station has to be finished. You know, so there's a lot of production pressure and program pressure. Same with you. And obviously, you know, those things put pressure on right first time as well. So that put pressure on everything. So yeah, that's true.
And also there was something very nice which somehow I resonate from time to time when I heard the presentation. It's about when you are going to improve the system, you are doing those improvements. You don't insert too many new variables in a system, one by one. Put something new, leave it to see how it develops, then the next one if it's needed, and so on. That is also something interesting to find out that some of us maybe think the same like me. CCIS switch.
Yeah, it's one of our sisters. I remember when we were working on the curing again with Dr. Williamson. Part of the problem is that sometimes you think you know something in terms of engineering, and you assume you know something, but actually you don't. And sometimes you've made an assumption, and that assumption is wrong. So everything you do has to have a step-by-step process where you prove that process. You know, it's like Rumsfeld, the known unknowns, the unknown unknowns. And it's the unknown unknowns that always trip you up. You know, it's very easy in engineering to assume you know something, and actually you don't. So
you know, I mean, we obviously we rely on people's experience, and experience is very, very valuable, but you problem solve based on facts and figures, not on feelings. So, you know, the experience can lead you to a cause faster, but your approach on fixing it requires data. You cannot just say, yep, that's it, it's done. You have to prove it.
I'm sympathizing with both of you, because yes, obviously experience comes with knowledge. You know, maybe also through experience what the issue is. You know also how fast to go to the, let's call it, books to see. But again, going to books already you insert the quality process in your thing, and that will double check exactly as you said. Double check that your experience is going to the right way or not. Because just thinking, oh, I know it's that one, then it's also a gate open to errors to come in.
Yeah, very true. And so you may find, you know, I certainly have, I've seen this before. This is what it is. And actually, your customer symptom can have several causes which cause that. And you will never know which one it is until you put in your control plan about what you've done to improve it. So you may do something and it improves it, but you may do something else and it improves it. So there can always be many causes to one problem.
Yes. That's cool. Anything else, James?
So fantastic presentation, Chris. Thank you. So what I was wondering was, you know, we talked about different models that Rolls Royce produces as part of the BMW group. Is there a difference in the sort of like quality levels or levels of defects that are acceptable on, say, a Phantom compared to a Ghost, then maybe compared to a 5 Series built in Germany, for example?
You're trying to work out which one to buy?
So the way we operate is through a BMW system. So they are classed, faults are classed exactly the same. The specifications are exactly the same for, tolerances. There is no difference. The only difference is we hand build our cars, not robot build them.
So that makes it harder, surely, when you hand build stuff because there's more variables.
Yes. But then we're not producing one every 40 seconds.
Is that amazing? Wow. I just can't even imagine that.
We're, big plants are in excess of, 6,000-7,000 units a day. That's what we do in a year.
Oh, that's incredible. Incredible. Yeah, I didn't realise that. That's amazing.
If you look at kind of Plant Munich, Plant Spartanburg in the US, they make all the X series, they're in excess of 5,000 units daily, 6 days a week.
Yeah, that is absolutely incredible.
They still have weekend, they still have that.
I suppose, the volume of stuff we produce here is equally as enormous in terms of the concrete. I mean, I was there on the day we poured the millionth cube of concrete. So, yeah, you just don't see that coming, but it's, I suppose when you start adding up the numbers, they're just absolutely mind-blowing, aren't they? So, yeah. Yes, incredible actually. Until somebody actually tells you how much that is, you have no idea. Incredible. Does anybody on the line have any questions for Chris?
I have a question. Obviously, I think most people have heard about sort of the Alaska Airlines loose bolt situation that happened earlier in the year.
Yep.
And on this project, we take a lot of lessons learned from other projects run by different companies. Do Rolls Royce do something similar? Do they look out to other industries that are sort of safety critical and take lessons learned and sort of capture that in improving their processes?
So the automotive business that we're in and the and building airlines is actually very, very similar. So the kind of processes we use, they are all very similar. We would look at that, but then, for instance, the bolt loose. All our critical fixings are done up with a computer generated torque gun. So we know if anything's loose.
Yeah, and also oversighting, so you can't oversight stuff either, which is just as bad.
Yeah. But yeah, we do, we're always looking to improve, and think things like that, but it would be kind of on an individual case.
How does that electronic device know which bolt is which?
So the associates, so say for instance, like on a door, you have a top bolt and a bottom bolt. It's not, they always have to start with the top bolt. Now, if they didn't start with the top bolt, then yes, but the process confirmations that are done daily, so on each associate there will be probably 2 or 3 process confirmations just in their area a day, so you would never have more than a few cars, and then from that you would highlight the issue, then we would obviously system check everything to check that.
Okay, so
yeah, there's always a sequence that they have to do the bolts up in, and generally we don't have many bolts that are the same torque, so they have different torque guns for different bolts.
Yeah. So basically the problem can never get too far in front of you, can it, if you're checking that frequency?
Yes. Yeah, and that's critical.
Because I suppose most things on a vehicle are safety critical, aren't they? So
Yes, they are. The majority of things are. You have all your brackets for all your airbag fixings, your seats, your suspension, pretty much everything.
yeah. Good question, Amelia. I like that one.
That's also a thing, because if you also think about from the other perspective, when you have very less things that are repetitive, it's also easier to control, and also it's a small change which raise awareness. When you have to plan 1,000 bars which are having the same dimension, the same spacing, sometimes too much repetition can just lead to a mechanical thinking that
Yeah, it's not, and also it tends not to be. We don't check stuff to this level. I mean, I'm hoping that when they start sticking the shiny bits in the building, they will be. They will be checking it to this level. We'll see.
On the steel structures, we are checking the things at this level. The bolts from the connection, they are checked with the dynamometric key to check the torque as well, especially when they are high strength bolts, which they are. And also on the steel structures, the tolerance is, I think, up to 16, 18 meters is like 0. 1 millimeter, which is nothing. While on concrete, we have the plus 10, plus 20.
Yeah.
20.
Yeah, that's. It's the controls, isn't it, which count here, isn't it? And the data. So yeah, without those controls and the data that they generate, you can't really hope to improve stuff, can you? So.
No, and the DC tooling obviously is that is how BMW operate throughout the globe with bolts, but I can almost guarantee you the reason they introduced that is because someone didn't do up a bolt and they probably had a recall at some point like that. And I would probably think Boeing will be doing the same now.
Yes, that was a pretty serious incident.
I'm very, very surprised that that kind of thing has got out into the public. That doesn't happen in automotive. Loose bolts like that doesn't. It can't.
That's reassuring.
As a Boeing shareholder, I'll be waiting for the NTSB report, which should be not coming. So
I'd be quite comfortable driving my Rolls Royce home this evening.
I was hoping, Chris, you could possibly bring one and turn up in person. Stick on your laptop. Yeah.
I'm doing the same. I'm driving my Rolls when I learn to fly with my Airbus.
Chris, thank you very much. Really appreciate that. Super interesting. And thank you
problem.
Very well. Perhaps we can get you here in person one day.